Okay, we are going to be studying homogeneous equations of the form P of t, x double prime of t, plus Q of t, x prime of t, plus R of t, x of t equals 0, where these coefficient functions p, q, and r are polynomials. Or they are polynomials. Okay, and what we want to do, kind of like the main idea, is the following. We're going to assume that the solution can be represented as a power series centered at some point t naught. Okay, but to do this, there's a couple of technical aspects we need to deal with. So first of all, observe if p of t naught is equal to 0, then at that point, the equation is really more like a first order equation. Okay, that's a little bit confusing, but what I mean, so if you go up to this equation, if t naught is equal to 0, well then that term is equal to 0, and you're just left with a first order differential equation. Okay, so we want to assume that p of t naught is equal to 0, and such a point is called an ordinary point. So if p of t naught does not equal to 0, then t naught is called an ordinary point. Okay, in upcoming lectures, we'll see what happens when p of t naught is equal to 0. That's called a singular point. Okay, but for now, p of t naught is called an ordinary point. T naught is called an ordinary point if p of t naught is not equal to 0. If t naught is an ordinary point, there is some neighborhood on which p is not equal to 0. Then p of t never equals 0 on some interval containing t naught. And so why is that? Well, I'm just going to write the graph down here, or do that explanation down here, so forget about this for now. So let's say this is the t-axis, and this is p of t. This is the graph of p. So let's say this is t naught. So notice that p of t naught is not equal to 0. Okay, since p is continuous, there's going to be some interval around t naught where p of t is not equal to 0. So we know p of t is continuous because it's a polynomial, and so we know there's some interval around t naught at which p of t is not equal to 0. Okay, and again, that's because of continuity. We know that there has to be some open interval around t naught where p of t is not equal to 0. And the fact that we're going to use is the following. The solution to the ordinary differential equation is a power series, or can be written as a power series centered at t naught on the interval where p of t is not equal to 0. Okay, so the idea is we're going to write the power series, and we'll go over this more in the next video when we solve a problem. We're going to write the power series in this form, and we're going to take this power series and plug it into the differential equation, and that's going to give us information about the coefficients. And we know that we can determine, and we know that we can do this by this fact right here. We